Hello, this is MEI Further Maths Core Pure. We're in the first matrices section and on the second video on multiplying matrices. You can watch the video straight through, but you will probably find it helpful sometimes to pause the video and try things out for yourself before continuing to watch. To multiply two matrices, we multiply each row of the first matrix by each column of the second matrix in turn. So in this matrix we multiply 1 by 2 and 4 by 2 and add them together to get the first element in the top left hand corner. For the next element we multiply 1 by 1 and then 4 by 3. That gives us 13, so that will be the top right element. Then we multiply minus 2 by 2 and 1 by 2, which gives us minus 4 add 2, which is minus 2. And finally we multiply minus 2 by 1 and 1 times 3, which gives us minus 2 add 3, which is 1. What about these two matrices? What size matrix would we get when we multiply these? Pause the video for a moment while you think about it. OK, we take the first row of the first one and multiply it by the first column of the second. That will give us the top left. Then we take that first row again and multiply it by the second column. That will give us top right. We take the second row by the second column. That will give us an element there. And finally the second row by the second column, which will give us an element there. So we get a 2 by 2 matrix. Let's do this multiplication. So, taking the first row by the first column, that gives me 2 times 1 is 2, plus 3 times 2 is 6, plus 1 times minus 4 is minus 4. Then the first row by the second column, 2 times 2 is minus 4, 3 times 0 is 0, 1 times 5 is 5. Then I take the second row times the first column, minus 1 times 1 is minus 1, plus 2 times 2 is 4, plus minus 4 times minus 4 is 16. Finally, the second row times the second column, minus 1 times minus 2 is 2, 2 times 0 is 0, minus 4 times 5 is minus 20. That gives me 2 add 6 take away 4 is 4, minus 4 add 0 add 5 is 1, minus 1 add 4 add 16 is 19, and 20 add 0 take away 20 is minus 18. What about this pair of matrices? If I try and multiply, I'm trying to do 3 numbers multiplied by 2 numbers. So these matrices are not conformable because they're not the right size and shape to make it work. If I want to multiply a pair of matrices, I need the same number of columns in the first matrix as I have rows in the second. If I write down the order of the matrices with rows and then columns, you'll see that the inside numbers have to match. And when they don't match, it doesn't work. OK, let's try some more examples. I want to find a squared, so that's a multiplied by A. Pause the video while you have a go at doing this one for yourself. OK. First row times first column. That's 36, add 4. Then first row times second column. That's 6, add 2. Second row times first column is 24, add 8. And second row times second column is 4, add 4. Working that out, we get 40, 8, 32 and 8. Have a go at AB. This time I've got some letters involved. That doesn't matter, we just use normal rules of algebra. So I've got 6k plus c, and then 6 minus 6, and then 4k plus 2c, and then 4 minus 12. That gives me 6k plus c, 0, 4k plus 2c, and minus 8. There's a bit more to this question. We're told that AB is 8, 0, 0 minus 8. And we've just worked out that that's 6k plus c, 0, 4k plus 2c, and minus 8. And we're asked to find the value of k and the value of c. Well, if we look at these elements, we can see that 4k plus 2c must be equal to 0. And that means that 2k is equal to minus c. If we look at these elements, we can see that 6k plus c is equal to 8. 2k is minus c, so 6k is minus 3c, plus c is equal to 8. So that means that minus 2c is equal to 8, and therefore c is equal to minus 4. That's equal to minus 2k, so k must be equal to 2. There are more notes on integral on multiplying matrices. That's the end of this short video. The next video in this series is on properties of matrix multiplication.